5 Keys to Building an AppSec Program in the Age of DevOps by Tim Jarrett.
Thanks a lot, Bill. Thanks for hanging with us while we worked out some audio stuff, guys. Big hand to the organizers, by the way, for jumping on that. Thanks, guys, very much. Before I get started, so this is my Reese's Peanut Butter Cups talk. We are getting AppSec in your DevOps and DevOps in your AppSec, and they are two great tastes that taste great together. My question before I get started is just so that I understand who I'm working with. If you are currently kind of doing an AppSec type job, or that's the tribe that you identify with, could you show your hands? Okay, we got a handful of people in the audience. Folks who are actively doing software development right now. Folks who are kind of involved in both. A couple of hands. That's awesome. So this talk is for everybody, but I'm going to try to kind of pivot across those perspectives as we go. Sorry. Oh, yep. So this is me. So it's timely. I am probably the only Grammy award-winning product guy that you'll ever meet. It's not my fault. I was on a recording with the Boston Symphony that got a Grammy about 7 years ago, which is the one random weird fun fact about me, that and my relationship with the Soup Nazi. More pertinent to this talk, I've been at Veracode since 2008. I came from the software development world and started doing AppSec when I got to Veracode, and I've seen a lot of different kind of interesting clashes between those two worlds over the years that have gotten more interesting, not less, as DevOps has kind of taken off and started to build momentum. And that's what we're really going to start with, is to understand the essential kind of conflict of worldviews that we're dealing with, because fundamentally DevOps is not about technology, it's not about pipelines, it's about getting people aligned behind common goals, and then using process and technology and other things to drive forward to deliver software that meets the goals of the business. So this is kind of where we came from, and where I think a lot of organizations still are, is this fun culture clash between development on one side and ops on the other, right? And I suspect that some of us recognize these worldviews because they're representative of how development and ops have traditionally been incented. Traditionally, development is incented to push change as quickly as they can so that the business can ultimately make more money, right? That's what it's all about. Where ops is incented to keep things as stable as possible, and traditionally change has been the enemy of stability. And what happened with the DevOps movement was a recognition that you have to align those two drivers and get everybody working along the same purpose. Think of the whole business as a system before you can actually bridge that gap and start making better software faster, right? Well, with AppSec, you're kind of back in that culture clash, because you may have bridged the gap between development and ops, and you're deploying in minutes, but if you're still looking at security from a perspective of checks and gates and things that have to be inserted into the process, and that perfection has to be attained at every step of the way, then you're still in that culture clash. And I would argue, and we're going to spend a little time talking about this, that the job of security in DevOps is to enable the business to go as fast as it can, as safely as it can, number one, and number two, to address the traditional concerns of security. Because if you're very, very safe, but you're not shipping software as fast as your competition, then ultimately you're not meeting the needs of the business either, right? So that's a little bit of what we're going to try to dive into this morning. So, the culture clash in development security goes deep. This is DevOps Days Austin. This is probably the most famous image that you'll find. It's the #1 Google hit for DevOps and security in Google image search. And I think that I've been among AppSec long enough, security folks long enough, to say that this is a characteristic of our tribe, right? Let's engage in some introspection here. We're all naturally very skeptical of technology movements that promise perfection, because we know that technology is imperfect, right? And so, when the DevOps unicorn comes along and promises, rainbow swirls for everyone, the security professional's mind's, natural instinct is to think about all the ways it can go wrong. So this is, a manifestation of that culture clash, right? I will be the first to say that I have manifested the culture clash myself, right? You know, I have been very guilty of saying publicly things like, you know, containerization is great, but unless you're doing it with security, you're an idiot, which is not necessarily the right way to think about it. You know, you really need to be thinking about what is the business benefit that you're trying to get to through adopting these technologies moving faster, and how can you help organizations move faster to do it. So I think it helps to look not at the way that the market of tools that security that even some industry analysts define DevOps, which is really limited to this vision of the CI/CD pipeline right? And that's kind of the perspective that a lot of people go to when they start thinking about DevOps. And to go back to first principles, go back to what Gene Kim talks about in the Phoenix Project, and some of the things that he then expands upon in the DevOps handbook, and talk about what it is that we're trying to do here, right? And this is, you know, not intended to be a full introduction to what DevOps is. Go read those two books if you want that. But, you know, just for the sake of refresher, we're talking about systems thinking, where we're not thinking about dev as a silo, ops as a silo, or now security as a silo either. We're thinking about the end-to-end process through which those groups work together to deliver value to the customer. So that's the first way, systems thinking. The second way is getting feedback loops, so that when something goes wrong in part of the process, you get it back to the beginning as quickly as you can so that you can correct it. And the third way is continuously experimenting and learning, so that as you continue to go down this path, you continually find better ways to improve your process so that you make things better. And none of this is new, right? These are all insights from manufacturing, from assembly line, from Deming, from half a dozen what would be considered boring old management topics, if we were talking about this 10 years ago, but that all have a lot of relevance to how software is made. So from a security perspective, what do we kind of want to think about with these three principles, right? Number one, security is part of the system. It's not outside. It's something that happens during the process of software development to ensure that you are delivering secure functionality that can't be hacked or taken over by an outside actor. It's also part of the operations function, because you want to actually understand what's happening to the code that you deploy while you're in production and respond quickly if something security relevant happens. You're part of the feedback loop, because if something happens from a security perspective along this pipeline, you need to very quickly get back to first principles and help the folks who introduced that issue understand it and correct it. And security has unique knowledge that helps people do that. Most developers don't understand the AppSec threat landscape. They don't understand secure coding principles. So security's job is to help enable them to respond to these feedback loops. And number three, engaging in the culture of experimentation and learning so that everybody's getting better at getting better. And so when you do that, you can really start to think of security as part of this assembly line, as part of this factory. And so what we're going to do as we go through the rest of this presentation is talk about some concrete ways that we can take that idea and pull it backwards. But first I want to talk a little bit about talking about security with folks who are doing DevOps and practicing DevOps, and help you understand a way that you can frame it so that they understand kind of why this is even a concern. There's a guy that I work with whose name is Jim Yastrebsky, and I'll spell it later if you're interested in looking this up. It's worthwhile. Who spends a lot of his time talking with developers about security issues, and he writes that it's a lot like managing people through the grieving process. You get kind of complete denial that there's a security problem. You get anger at the people that ran the scan. You get bargaining to try to push issues off the table. You get sadness and throwing up your hands that security is futile, and eventually you get to acceptance, which is you're actually engaging with security in the process. And the problem is most developers never get past the first two stages, right? So I think that part of the challenge that we have with security and development is that security is a completely different sphere, and we don't often talk about it in terms that developers understand and are motivated to think about. So I'm going to do something that I do with most developers who aren't working at a security company, and talk about this in terms of quality instead. Because ultimately what we're talking about when we're talking about secure coding standards is building a better application that's more resilient in production, but instead of being resilient against things like resource consumption and misunderstanding business requirements and the sort of things that are traditionally the domain of quality, here we're talking about resilience against attacks. Counter to what a lot of AppSec professionals told me when I first entered the business, I think developers actually do care about security in as much as it's a reflection of the quality of the code that they're writing, right? And so I think that it's important to make that mental shift, and it's very important in the context of DevOps because DevOps has already gone a long ways to helping developers understand how to embed quality checks of other types into the code that they're writing in the software development life cycles that they're automating. And the reason that the quality is important, and the other motivating factor that I bring to developers, is understanding kind of the impact of the overall issues. I liked the keynote this morning when Robert talked about the need to move away from high, medium, low, and talk about security issues in terms of actual business impact. This visualization is as good an illustration of this as any that I've found. If you go to Information is Beautiful and you look for the world's biggest data breaches visualization, you get this cool interactive explorer that talks about recent breaches that have happened. The bubble size is how many records were affected, and the color code is what's known about how the breach happened, what's the actual cause. And you can pop down a filter here and start to turn off things like something was misconfigured, something had a security bug, there was a hack, sorry, there we go. And if you go and do that, and you turn off all of the things that are relevant to AppSec, here we've turned off configuration error, hacked, and poor security, and we've left on things like lost or stolen computer, lost or stolen media, inside job, accidental publishing. Let's look at that again. So those are the big bubbles, right? And they mostly disappear once you turn off the AppSec relevant stuff. So this is your connection from a quality perspective between failure to write things securely and the sort of outcomes that end up with your company being in headlines and paying fines to regulators and with lawsuits from customers, right? And just to connect the dots one more time, most of the security vulnerabilities that we're talking about that are implicated in these hacks are common coding errors that are present in most applications. Veracode does a study across hundreds of thousands of applications every year that looks at the prevalence of common vulnerabilities. And what we see is 35% of all the applications that were assessed had a hard-coded password in them. 32% this year, and this is data that was published in October of 2016, State of Software Security Report, are vulnerable to SQL injection, allowing some sort of data theft. 28% have open redirects so that you can chain that together with other types of attacks, and a full 50% of all applications that we analyzed, inclusive of applications that aren't necessarily subject to web vulnerabilities like applications written in COBOL, actually contain some sort of cross-site scripting vulnerability that would allow an attacker to execute code in the context of the browser. So this is why we want to connect the dots and motivate developers to start thinking about preventing these sort of issues, not after an audit has failed, not after somebody has come and run a penetration test on a piece of software that's already in production and told you that you need to make a change, but earlier in the process, ideally as close to when you introduce the issue as possible. And ultimately, what we're after is trying to get to a partnership between the AppSec side of the house and the development and ops sides of the house, so that everybody's working together on the same airframe and getting things flying down the virtual airfield as fast as we possibly can. So now let's talk about the practical how-tos. And I'm going to boil this down to 5 arbitrarily numbered principles that we're going to talk about. The first is around automation. I said that DevOps isn't just the CI/CD pipeline, but a lot of DevOps centers around this innovation, which is really taking automation and manufacturing principles into the process of building and releasing software. And we're going to talk about how AppSec tooling and processes fit into that. We're going to talk about when you do that in the pipeline, and our bias is to as early as possible, but no earlier. We're going to talk about the importance of managing the noise of AppSec tools in the pipeline and some of the issues that you can run into with that. We're not going to neglect the fact that I said at the beginning that a lot of this is about people and process, because we're going to want to talk about the role that AppSec plays in helping people understand the findings, and what do you want to do about the fact that there aren't enough AppSec people in the world to engage with all the development teams in the world. And last but not least, we'll talk about the fact that this doesn't end in development, that because we want to think about this in a systems model, we're going to try to think about what we do with AppSec in terms of production as well. So let's start with automated security as our first perspective. So if the push in DevOps is to take that which has been historically a guild-based, craft-based approach to building software, I think a lot of us that have been in the business for a long time will recognize the thought that software has been built by artisans traditionally rather than in a predictable and repeatable way, right? And the same is true with how we've done security as part of that process. We've had very skilled people, and I think many of you in this room probably at one point or another, engaged in the process of figuring out how somebody can break an application, which is awesome and necessary and doesn't scale, right? So I'm not saying we stop doing that which is manual, artisan-like, and really high quality in terms of breaking applications, but I'm saying we find ways to supplement that in the process of automatically building software with as much that you can do in the way of automated testing as possible, so that we can catch the low-hanging fruit, we can make sure that obviously glaring things don't fall through the net, and we can ensure that as we continue to build and deploy software more and more rapidly, that we are doing what we can without contributing to the world's shortage of InfoSec professionals to actually address issues that may be inserted during the process by poor coding practices. So what am I talking about? Well, there's a whole technology landscape of AppSec tools, and what you're going to use is going to depend on a couple of things, primarily the type of your application, the level of coverage that you can afford, and how much you're going to trade off in terms of speed for that. And ultimately, I think the third piece is what your development practices are. So, from the top, static analysis, inside out, looking at the code that your developers have written to identify security vulnerabilities. Pluses, you get very good visibility into what the development team has actually written. Minuses is you miss out on deployment context, and historically these tools have been on the noisier side of the security tools that are out there. Software composition analysis, which deals with the threat of including out-of-date components and never updating them again, and therefore inserting known vulnerabilities that attackers will go after into the software that you're using. There's a new category called interactive application security testing, which basically means you're instrumenting the runtime and reporting from within the runtime when you see some sort of security relevant behavior, which is cool, but which also depends on making sure that you have full coverage of all the code paths in the application to actually report the vulnerability. If you're doing interactive testing and you never go down a path that has a vulnerability in it when you're using the application, the tool doesn't report it. And then dynamic analysis, which I think a lot of folks are familiar with in the context of kind of going through and scanning for vulnerabilities in a web application. And that's a well-known, very mature tools category, but because it relies on crawling a web application in real time, it's also one of the slowest of the automated technologies. So what does that mean from a practical perspective? It means we look for ways to do static analysis that are fast and low noise. We look for software composition analysis if we're using open source components in our software, which most, at least Java developers are doing. We look for interactive, it's an early stage technology, so evaluate it and see if it makes sense for you. And if you're doing dynamic, try to minimize your reliance on crawling the application and go for a guided scan of where vulnerabilities may be, and use it more as a full application verification technology and maybe think about doing it in a different way in the pipeline than gating your build on the results of that tool, and we'll talk about that in a second. It has to be automated not just in the running of the application testing, but also in the way that the tooling gets invoked and the results get consumed, which means you need APIs. And again, we're not saying don't do penetration testing. We're saying don't gate the release of your software on it. It becomes, when your software is changing 5 times a day and you're trying to do a penetration test against that moving target, it makes sense to think from a business perspective on what frequency actually makes sense to get those business insights about where your code is falling down. I work with a team of developers at Veracode where the rule is you do a small-scale penetration test every time a new feature is introduced into production, and you do a full-scale penetration test with an outside group on a periodic basis to satisfy customer requirements. So a model like that might work for you. Let's talk about when you do this. Again, we said our bias is as early as possible in the development lifecycle, but no earlier. So why is that? Well, what we know from engineering is that if you don't, from manufacturing, is if you don't catch errors as soon as they're introduced, what you end up with is a situation where the errors get caught very late in the cycle. They go backwards in the manufacturing process, creating enormous disruption to the flow of the work product through the factory, and basically causing an enormous hit on your ability to deliver stuff. And the same thing happens in the delivery of software. Issues that are found late in the development process, long after the code is written, are hugely disruptive to software developers, and that's honestly one of the reasons why a lot of software developers really don't like security people, because they show up with PDFs with 200 pages of vulnerability findings 6 to 9 months after the code has been written. You have to find the developer who wrote it. Attribution is always fun. You have to figure out how to go in and make that correction. You have to figure out how little of that you can get away with correcting so that you don't totally blow your schedule, right? Whereas if you were able to check for these issues closer to when the developer wrote the code, then it's a much faster correction mechanism, and by the way, the developer actually starts to learn what it is that they're doing wrong and code more preventatively in the first place. We talk with our customers about what technologies to deploy and how early to deploy them in the process. I'd love to be able to give you a one-size-fits-all prescription here, but the reality is that dreaded it depends. And it depends because there's a couple of things that are going on. Different organizations are at different stages of maturity in building out automation and building out this continuous integration pipeline. So some folks may have most of the steps automated, some folks may not yet have all of their quality unit tests integrated, and there's a hierarchy of needs with this stuff. If you aren't verifying that the software is going to run in an automated way, then doing automated security testing is of limited value, right? Get the unit tests working first, and then start to work on the security stuff. The other thing is that software itself is changing. One of the things that we find is that there's a push that's complementary to DevOps to reduce the size of the code that you're actually pushing through the pipeline so that you minimize the number of disruptive code path exercises that you have to go through to figure out how to fix things that are broken. So that's where the move to microservices comes in. So if you have an application that is a 400 megabyte Java WAR file, I might have a different recommendation for how to do security testing in your pipeline than if you have a fleet of microservices coming through that are like 5 megabytes in size or less. So what are the options? Well, kind of going from the middle out. The most common thing you see people recommend is to automate this testing in the deployment pipeline. And the most common integration point is your continuous integration server. Jenkins, VSTS, even doing this in Maven are all ways that are legitimate to go about the process. And what you do with the results of the test depends in large measure on the characteristics of your application. If it's a 400 megabyte WAR file and you want to scan the whole thing end to end, you probably don't want to wait for that end-to-end scan to finish before you decide whether you're going to pass or fail the build. You probably want to run that asynchronously and then send any findings that are found into the defects tracking system that the development teams are already using and triage them alongside other issues. On the other hand, if you're testing small microservices, if you're testing smaller increments of code, you probably do want to stop the pipeline if you find a security issue so that your developer can fix it as soon as possible. Moving left, one of the things that we're starting to see people do increasingly is arm the developers with the ability to run static analysis even before the code enters the pipeline, which is much closer to the point where they introduce the issue, and it allows them to learn much more quickly. So there are what Gartner is starting to call SAST Lite, static application security testing light tools that run from within the IDE to allow the developer to run a static test in seconds. There have been some of these products in the industry for a few years now, products like Secure Assist. There's a second wave of those tools coming into the market now that if somebody wants tool discussions afterwards, I'm happy to do, that are there really to help developers to test their code right at the time that they're writing it and to learn from any coding errors that they may be committing. And then I want to think about moving right as well. Now, if I've just said that we want to test as early in the pipeline as we possibly can, why would I be talking about testing in production? Well, for a couple of reasons. One reason is that there's sometimes things that happen in the context of the security system that you don't see unless you have a fully running application with data, with all of the services behind it. You want to actually be able to test that whole system in an integrated way. But you also want to be getting code out to customers as soon as possible. Well, DevOps and CI/CD have a pattern for this. It's called feature flagging. It's called blue-green deployments. And basically what you do is you make a gradual rollout to the user base and only roll out to the entire user base once you've reached your acceptance criteria, such as monitoring for availability, such as getting UX feedback from a small group of users that you've turned out to, maybe such as running a full-scale dynamic test on a code base before you push the load over to that new branch. So I think that there's some room for folks to think about when does it make sense to actually do a full system test in production and use the blue-green deployment pattern to actually enable us to be able to do that in a safe and secure way. So all of this only makes sense if you've got good data coming out of the security tools that you're using. There is a challenge with false positives historically in the business, and that's because, again, there's a clash between what security professionals need and what developers need. Security professionals are historically terrified that their tool will have a false negative, that they'll miss something. So they turn the gain way up on the rules that are being run. And the problem is that typically what happens there is that you get a lot of noise coming along with those extra true positives that the tool then reports. So, I think that the priority from a development perspective has to be making sure that every result that's reported is as accurate as you possibly can make it, because otherwise you're going to be throwing up a hand and saying stop the manufacturing line every time that a finding comes out. And if only one in every two of those findings are real and actionable, then what happens is that the tools get ripped out of the pipeline because they're not adding value and they're actually taking away from the business's ability to ship code quickly. So think about false positives as part of what you want to design for minimizing as you think about how to integrate AppSec into your pipeline. This is not all about tools. I promised that at the beginning. And the reason, ultimately, is that the folks that I see in the room and that are down there having a beer at the bar are a very small group of people relative to the need that's out there. The data that the LinkedIn folks presented back back a couple of years ago at Black Hat was that for every every 4 InfoSec positions that were currently filled in the job market globally, there were an additional 3 open positions that were just not able to be filled because there weren't enough qualified people. So the way that you deal with this is that you build champions who can do some of the low-hanging fruit for InfoSec, such as doing lightweight code review, such as answering questions for developers who are trying to decide how to do something securely, and such as looking at something that may be an issue and escalating them to the attention of somebody from a security team. And you build those champions out of the development teams that you're already using. You designate one or more developers in each team to serve the roles of these champions, and then you train them. And there are mature training methods that are proven to work, like computer-based training, like just-in-time short training to illustrate kind of how to address secure coding issues. But there's also practices that we've seen be very effective, like capture the flag exercises and other things that are more experiential learning for these folks. But the important thing is train them. Don't just say you're a champion and then don't give them any knowledge about how to deal with that and what that means. And last but not least, security in AppSec does not end once the code is deployed for a couple of reasons. Number one, you want to understand what does happen if somebody is able to successfully breach your application and be able to address that as quickly as possible, not just from an incident response perspective, although of course that's hugely important, but also because if something got through this process that we've built, we want to learn from it. And we want to plow those learnings back into the earlier stages of the process so it doesn't happen again. So what do you use for monitoring? Well, we go from the most mature solutions, like looking at your logs, right, to other solutions that are a little bit more fine-grained in terms of what they can report. Web application firewalls, for all their faults, can actually monitor for suspicious issues, and you can look for those. They can be noisy because they're based on packet inspection. There's a new category emerging called runtime application self-protection that sits inside the runtime, just like interactive testing does, but it does it at production. And you can run those and just watch for suspicious security events. Again, a new technology category, but I would recommend at least taking a look at it to see if it will help you get this sort of visibility in production. One way or the other, you have to track what actually happens to that code once it's deployed so that you can get the learnings back earlier in the process as soon as possible. So really, my answer to where do you secure applications under development in a DevOps process is you think about it at every step of the way, from when the developers are working to the build process. We had a talk earlier about container security, and I think that you do need to think about the security of the components that are being packaged in, to all the way out to operations. There are things that you can do in every step of that process that will help address the issue of security. And the beauty of DevOps is because it is this incremental model, you don't have to do it all at once. Pick one, get it working, iterate. Pick another control and implement it, get it working, iterate. And you'll be much more successful than if you try to take a big bang approach or if you try to concentrate just on one area of this pipeline. And I think that with that, I am going to wrap and see what questions people have in the room.
I think we can take one. Otherwise, thank you very much, Tim. Appreciate it. All right, no questions. Thank you.
Thanks very much.